Hello and greetings to everyone. Today we are to treat dimensions. We take down the heading dimensions. We take this down. The dimensions of a physical quantity is the quantitative measure of that physical quantity. It can also be defined as an expression that shows how a given physical quantity is related to fundamental quantities such as time, mass, temperature, current, and amount of substance. Substance through a defining equation. For example, velocity is defined as the rate of change of displacement. When we talk of displacement, that is in bracket, we take the bracket, we write this down. Displacement is simply distance covered in a particular direction. We can define velocity as length divided by time. If you divide length by time, you obtain velocity. Full stop. The dimensions of velocity are, take learn, we divide by time. You see that we can easily see the physical quantities, learn and time. Take this down, the dimensions of a physical quantity is represented using square brackets. E.g., example given, dimension of velocity is represented as such by writing velocity in square brackets, which means the dimensions of velocity. When we take this down, the table below shows the dimension of base quantities. We are going to represent it with, the table has two rows. The first row carries the base quantity. The second row carries the dimensional symbol. The first one, we have mass. It has a dimensional symbol, uppercase M. Next we have time. It has dimensional symbol, uppercase T. Next we have length. It has dimensional symbol, uppercase L. Next we have current. It has a dimensional symbol, uppercase A. Next we have temperature, which has dimensional symbol, uppercase K. Lastly, we have the amount of substance, which has a dimensional symbol, mole, like this. Now let's take down these examples on how we can find the dimensions of some physical quantities. Take this down. Example. It goes find the dimensions and units of following quantities. A, we have a velocity. B, we have acceleration. C, we have force. And D, we have power. We take down solution. A, velocity. Velocity is simply equal to, we take a displacement all over time. The dimension of velocity will simply be equal to the dimension of displacement. So in square brackets, we put the dimensional symbol, which is brackets L. Then we divide by the dimension symbol for time, which is T. We put it in square brackets. We can express this as L in square brackets times, remember, if you have E over B, can be expressed as E times B to the power negative 1. So this will give us L in square brackets times T in square brackets, all this raised to the power negative 1. So this is the dimension of velocity. Now let's write down the units. The unit of velocity, unit of velocity is, the unit for length is the meters. We place this L in square brackets with M. Then we multiply it by, we replace T in square brackets with S because the unit for time is seconds. Then we raise it to the power negative 1. The units of velocity, the unit of velocity is meters per second. We move now to B for acceleration. Acceleration is simply the rate of change of velocity, which is velocity divided by time. It simply means the dimension for acceleration it will simply be equal to the dimension of velocity divided by the dimension of time, and this will be equal to the dimension of velocity. This is it. We have L in square brackets times T in square brackets, all this raised to the power negative 1, raised to the power negative 1. You divide this by the dimension of time, which is T in square brackets as such. This will simply be equal to, we take L in square brackets times T in square brackets raised to the power negative 1 times T in square brackets raised to the power negative 1. This will simply be equal to L in square brackets times T in square brackets. Negative 1 plus negative 1 gives us negative 2. So this will give us L times T raised to the power negative 2. This is the dimension the dimensions for acceleration. Now, from the dimensions of acceleration, we can easily write down the unit of acceleration. The unit of acceleration is, replace L with the unit of length, which is meters. Replace T with the unit of time, which is seconds. Then this is raised to the power -2. Therefore, the unit of acceleration is meters per second squared. We go to the next one, C. For C, we have force. Force is simply equal to, it is defined as the mass times acceleration. It simply means the dimension of force will be equal to, take the dimension of mass times the dimension of acceleration. This will simply be equal to the dimension of mass, we have m in square brackets, times the dimension of acceleration, which is this, L times t to the power -2. This will simply be equal to m L t to the power -2, where we underline dimensions of force. From these dimensions of force, we can easily write down the units of force. We have the unit of force is, we are going to replace m with the unit of mass, which is kilograms. We replace L with the unit of length, which is the meters. Then we replace T with the unit of time, which is the seconds. And it is raised to the power -2. Therefore, the unit of force is kilograms meters per second squared. We move now to the next question, which is power. D, we are to find the dimensions and unit of power. Power is simply equal to the rate at which work is done. That means work divided by time. The dimension of power will simply be equal to the dimension of work divided by the dimension of time. We are to find the dimension of work. Work is simply equal to force times displacement. It simply means the dimension of work will be equal to the dimension of force times the dimension of displacement. From above, we had the dimensions of force to be m times L times t to the power -2. We had to multiply this by the dimension of displacement, which is L. This will give us m. L times L gives us L squared. We will multiply this by t raised to the power negative 2. Now we can proceed to find the dimensions of power. It will simply be equal to, we replace dimension of work with this, which is m times L squared times t to the power negative 2. Then we have to divide all this by the dimension of time, which is t. This will simply be equal to m times L squared times t to the power negative 2 times t is t becomes t to the power negative 1. And this will be equal to m times L squared times t to the power, we take negative 2 plus negative 1, which gives negative 3. Therefore, the dimensions of power, we have m times L squared times t to the power negative 3. Now we can easily write down the unit of power. The unit of power is, we are going to replace m by the unit of mass, which is kilogram. Next we replace L by the unit of length, which is meters. Then we square it. Next we are replacing t with the unit of time, which is seconds. Then we raise this to the power negative 3. Therefore, the unit of power is kilograms meter squared per second cube. We are done with the solution of the examples on how to find the dimensions and the unit of a given quantity. If in case you have any questions on what we have just treated, feel free to drop your questions at the comment section. Please, if you like the video, share and subscribe to this channel. In our next video, we are going to treat the principle of dimensional homogeneity.